we were discussing about the one-dimensional array and two-dimensional array. And in two-dimensional array, if you remember, we talked about that two-dimensional array is basically stored in the memory in the form of one-dimensional array only. Just the as it shows the values in the form of rows and columns, that's why we consider it to be two-dimensional array. So if we have to define a two-dimensional array, then in that case, if I define int a 3 3, so this shows the number of rows and this shows the number of columns. Okay. And for this thing, because we have defined it as an array, as a two-dimensional array, how we are going to assign the values? So in that case, you can write it as int b 2 2 can be given the values like this: 1 comma 2, 2 comma 4. Or you can ask it from the user like this: if I define C22, then in that case, then you can write for loop. You require, because it is two-dimensional array, so you will require a for loop. Two for loops will be required. So first for loop for the rows and second for loop for the columns. And here we can use the scanf statement. C, I, comma, J. And here we close the loop for the first for, this is for the second for. So this way we can read the values for the two-dimensional array as well. And as I explained in the last class, a two-dimensional array is something like this. If you want to enter, say, roll number of the student, say, marks of the student, and say, total attendance of the student. Okay. So roll number one is having, say, 14 marks and having attendance, say, 25. Roll number two, marks are, say, 16 and attendance is, say, 30. So this way, it is a two-dimensional array. If you want to store the data like this, then in that case, we use a two-dimensional array. And in that case, it will be stored, the values will be stored like this. So you can, if it is a two-dimensional array, then this is your column, that is J, and this is your row, that is I. So in I, you will have 0 and 1. Here you will have 0 and 1. So this will be represented as A00. This will be represented as A01. This will be represented as A10. And this will be represented as A11. Okay. So this is how we can define a two-dimensional array, and we can store the values in two-dimensional array. But again, I will repeat, in the memory, it is stored in sequential order like this. If you are having two-dimensional 2 cross 2, then this is the first block, this is the second block. First block is having two elements. So this is 0, this is 1, this is 0, this is 1, this is 0, this is 1. So basically this is this thing. Then 0 1 is this thing. 1 0 is this thing, and 1 1 is this thing. So this way we can define a two-dimensional array and we can allocate the values as well. Similarly, we can do for three-dimensional array. Then in that case, what will happen? If I define int a 3 comma 3 comma 3, then how you're going to get it, how you will get the values. So basically it is something like this. You have to think about a three-dimensional space. So this is I is equal to 0, this one is I is equal to 1, this one is I is equal to 2. Okay, and here j is equal to j, and this one is j k. So j is equal to 0 1 2, k is equal to 0 1 2. This one is having k as 0 1 2. This one is having j 0 1 2. So this one is having j. So if I talk about this one, so this one is represented by A000. If I talk about this one, then this will be represented as A022, because zeroth space from here, and this column is 2 comma 2. So 022. Okay, so basically three-dimensional space is something like you are having three. In this case, you are having three two-dimensional spaces. Why three two-dimensional spaces? Because third dimension is also three. If you are having here four, so we will say four two-dimensional spaces are there, and so on. Okay, I hope this thing is clear. Somebody is asking for the previous slide. Okay, done. Okay, coming back to this one. So we can define their rows, columns, and indices, total indices, on the basis of three different variable values. Okay, starting from 0 to the largest value minus 1. Largest value minus 1, in this case, if it is 3, then it is n minus 1. So it will go up to 2. So 0 to 2 in the row, 0 to 2 in the column, and 0 to 2 in the number of spaces. Okay, so these can be defined like this. What will be the value for this one? This one will be A2, because I is 2, then J is also 2, and K is also 2, because we are talking about this location. So this is from the second block, second row, and second column. So we have second blocks. So you can say this is the block number, this is the row number, and this is the column number. This will always remain the same. More than three-dimensional, yeah, we have it. We have multiple three-dimensional spaces, so we call them for. It is basically used in many of the applications, practical applications we have sometimes, but it is easy to define, and it is easy to have basic mathematical equations on higher dimensions, but it is very tough to work with the complex manipulation or mathematical calculations. So rather we convert the higher dimensions into lower dimensions, save them as lower dimension, and then we work on that. Basically, when we talk about this visualization space like surveillance and all, in that case obviously you are having the data in three-dimensional space. Why so? Because when we talk about a video, basically video is having multiple images. So the two-dimensional space is one particular image, and then we have the temporal data, which is number of images are there. So we have three-dimensional data in that case. But it is difficult to work with three-dimensional data directly. So nowadays we have started working on three-dimensional data in higher dimensions. We are working on that as well, but it is less popular. We can say that thing. Okay, so this is about the three-dimensional array, how to define them, and obviously when you want to read the data from the user, then in that case you have to define it like A3 3, 3. Then you have to use three for loops. One with I is less than 3, I plus plus. Then again a for j is equal to 0, j is less than 3, j plus plus. Then we have a third for loop for k is equal to 0, k is less than 3, k plus plus. And then we can scan f statement can be used here, percentage d. And what should be the value? A, I, j, and k. So this way, and close the all the for loops. So done. This is how we can read the values. Even we can make simple manipulations as well using these arrays. This is again the same thing, that even when we are having this sort of data, but how it will be stored in the memory is something like this, which is shown over here. It will start storing it sequentially. So how it will store, this one will be given. I will take another color. So this one will be given first, second, third, fourth, fifth, sixth. Then 17, then 18, then 19, then 20, then 21, 22, 23, 24, 25, 26, and 27. Okay, so all will be stored like this. How in the memory? If I say this one is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on up to 27. Okay, so in memory it is stored sequentially only, right? So for example, if I directly want to jump to this memory, okay, if I want to jump to this particular value, then you have two options basically. First one is using A100. If you know these indices, then you can jump to this one. But you don't know the indices, you only know the address. Then how you will go to this particular address? If you know the first address, say if this is 1000, then how you will reach to this address? We all for example, we are taking 4 bytes for int. If this is int and we are having 4 bytes, and to make it easy, I will take this one as 1001. So obviously next will be 1004, 1 2 3 4, sorry, 5. This one will be 1009. Then this one will be 1013, 1017. Then next one will be 1021, 1025, 1029, 1033, and we want to reach to 1037. So what was our target? I wanted to reach this address. How is it possible? I know that each one is using 4 locations or 4 memory locations. So if you multiply 4 by 9, what is the value? 4 into 9 is 36. And you add it to the base value. So what you will get? You will get the next value. So this thing is used in many of the programmings so as to find out the address where you want to get some value, from where you want to get some value, right? So this is required. Okay. But if we go to our programming, let me go to, wait, whether we can increment, uh, yeah. In the last class, we have seen this program, if you remember, where we are having hash include stdio.h, and we were reading the addresses and we printed the addresses on the screen. So sometimes it comes to our mind that if I can get the base address, can I reach the address of the fourth element or the third element? So let's see if it is possible. Definitely it is not, but even then, I am telling you. If I write here A, simply, what should be A? A is the base address of array A, right? But it will show you an error. It is showing an error. Okay. Even if I give this one address of the first location, if you say that please give the ampersand sign, and then let's see, no, it won't give us. It won't give you the value. Now, if I write this thing, then what it is going to do? Whether it will give you value? No, it is not giving you value. Why? Because B is of integer type, and this is, sorry, there's one mistake. Even then, it will show an error. Why? Because B is of integer type and this is some address, right? So either you need to typecast it using one method is there, void and all. We will discuss about it later. I won't discuss it right now. But you have to understand the concept that here you are you're not directly getting the address in a integer type variable, right? Even if we write, sometimes it happens that we try to write like something like this. Uh, Say A1 is equal to ampersand A0 plus plus, then it will also show an error. Here what I tried to do is I have tried to increment the address. No, it is not possible this way as well. Okay, it can only be done using the pointers, right? So don't think that you can increment the address and you can get the value. No, it is not possible. You have to use the pointers for that. Then only it is possible. Okay, coming back to our previous one. Yes, but definitely using pointers, it becomes very easy because you can just go to the next address and you can start working, right? Then this is about the three dimension. Then coming to this program where we are trying to find the largest number in an array. We are trying to use array and we are trying to find the largest number in an array. Then we have already discussed finding the largest number when you're having three variables. Wait, now it is working. Say we are having an array, maybe any name it is having. Say I am saying it as A double R. and it is having these values. These are the indices, and we want to find the largest number. Then very simple it is. You will take one variable named max and initialize this value to 0 initially, and then every time you will compare the values in the indices. It means first value is 3, so it will compare with 3. If max is greater than ARR first value, that is, I am using I for that, and definitely for that you will require a for loop because you want to compare it with all the values. I is less than 9, I plus plus. If this max is greater than AI, then what you have to do, you have to reinitialize the value of max as ARRI. And simply you will run this for loop. At the end, what will happen? This will have the maximum value. How? Because when 0 is compared with 3, 3 is larger. So 3 will be stored in max. So it changed to 3. Then when 3 is compared with 7, 7 is larger. So 7 is stored in max. Then it is compared with 5. No, it is not larger. So 7 will remain over there. Then it is compared with 4. 7 is larger. No, 7 will remain there. Then it will compare with 9. 9 is greater, so it will replace with 9. Then 10 is greater, so it will be replaced with 10, and so on. So this process continues. So this is very simple. Okay, if I go to the program for this one, then it is very simple. We are reading the values from the user in an array. We have defined one array. We are reading the values from the array. Then after storing the values, what we are doing, we are comparing the values, and then in that case, simply in this case, what they have done is, instead of taking max as 0, they have taken the first value AR000, ARR0 as the initial value, and they are going on comparing this with the next value. If this is the condition, then it will bring the maximum value. So a little bit of change, both are correct. So how many elements you want? I want 5 elements. So I will enter 6, 9 here, then 3 here, then 4 here. Largest element is 9.00. Why 9.00? Because we have taken the array as, you are not able to see the output screen. All of you are not able to see the output screen. Okay, let me share it again. Wait. Now is it visible?
Yes, ma'am.
Now is it visible? Okay. So I'm taking 5 elements. I'm entering 5 elements here. Sorry. So it is giving me the value as 9.00. Why 9.00? Because I have taken the array as, if you see here, we have declared it as float. Okay, this one. So that's why it was giving me 9.00. If I take it as int, then you will get the int value. Okay, so this is very simple to understand, that how to find out the maximum value in an array. But what about if I want to find out the second largest one? Then in that case, how to find? If say I am having this array, So these are the indices 0, 1, 2, 3, 4, 5, 6. Okay, so 7 elements. And I am having some value. We are having these values, right? Then in that case, how to find out the second largest? First largest was easy to find. We were comparing the minimum value every time with each element, and whatever is the maximum value, we were storing that value. That was very easy to do. Now this case, how we are going to do it? For the second largest element, what we will be doing, we will take two variables. One is the largest, and second is the second largest. S is the second largest. And what they have done in this case, this I have put intentionally because this is one function which is available in limit header. It is not compulsory to use this. You can use even zero or any value, or even the first value can also be considered. But this I kept it intentionally because if you want to use this thing, you have to use limit.h header file. And what this will do, this will give the minimum value of integer as the input. Okay, so this is the minimum value of integer. If I am talking about 2 bytes, then it is 32768 67, sorry. Okay, negative. So that is the negative minimum value in case of 2 bytes. Okay, so it will be assigned to this one if you are considering int min. Otherwise, what you can do, otherwise, no need of using int min here. Simply, what you can put is you can use 0 here. Instead of this, you can use 0 here. Okay, now what you have to do, you have to use a for loop definitely. What is the size? It is the maximum length of the array. So in this case, if it is, it should be less than 7 I plus plus. What they are doing is they are comparing the value, this first value, with the L value. If it is greater, if this value is greater than 0, definitely it is greater than 0, then what it should do? It should change the value of L. And what it should do, whatever there the value is in L should go to the second largest. So they are using that concept that if right now what will happen, L is having 0, S is also having 0. So when 5 is greater than L, what you have to do, L should be 5 and S should be equal to L, right? So S will be 0, right? Then we go to the next one. It won't go to else part because this condition is true, so it won't go to else part. We will come to else part also when it will go to else part. So it will come to the next one, means 15. What will happen? Right now, what is L? L is 5. So this value 15 is greater than L. Yes, true. So what should be L? L should be 15. Then where this 5 will go? 5 will go to S. So S should be 5 and then L should be changed to 15. You have to reverse the order. It should be after this. Otherwise, your value will be moderated. Then it goes to next one, 25. 25 is again greater than L. Yes. So what to do? Shift the value of L. What was L? 15 to second largest and give L a new value, that is 25. Then coming to 10. Is this value greater than L? No, it is not greater than L. So it won't go to if, it will go to else. Now what we have to check? Whether this value is greater than second largest or not. It is definitely not largest one. But it can be second largest, no? So if it is less than the largest value, for example, if it is 17. So in this case, if you see largest is 25, which is higher, no problem, but it is more than 15, right? So second largest should be 17, not 15. So we will check over here. It is greater than S. Then what we will do, we will update the value S. L will remain same, but S will be updated to 17 now, right? And this way we will go on proceeding till the end. Here, if you see, one more thing is given. This value is not equal to L. It is not greater than L, but if say it is equal to L, say for example here instead of 12 it is 25. So 25 is already here now. So it should not be assigned to S. So what to do? So in that case, it should not be considered. So that's why we have used a AND operator here, and we have considered that it should not be equal to L. Then only it will go to second largest. If it is equal to L, already we have considered that case, right? No problem. Okay. And second largest will have the second largest value. But if you're having this program, then there is one problem. If say I am having an array, say it is having 5 values, it is having all tens, then what will happen? Check it. I will pause for a minute for 30 seconds. Just check what will be the value of L and S if all are 10. Okay. So in that case, what will happen? Definitely, yes. It will have L as 10. Yes. Because first value is greater than 0. So L will have the new value as 0. S will have 0. Sorry, L will have the value of 10. So L will be here in the first case itself. Sorry. L will have 10 and S will remain as 0. Next time what will happen? No, it is not greater than L. Next value is not greater than L. So it won't go to if, it will go to else. Else also, this value is not greater than S. ARRI, second value, means I am talking about this value. This value is greater than S. Yes, it is greater than S. So it will be S, right? So what will happen? Finally, what will be printed? Whether it will print no second element will be printed in this case. But whether the value of S will be changed to 10 or not, this is my question. No means what? Value of S will remain 0 or no change?
Remain 0.
We are not considering this part for a while. We are not considering this part for a while. Yes, because what will happen, it won't change. I will tell you why. What will happen in this case when for the first time 10 is greater than 0, so it is taking 10 is greater than 0. Yes, true, it will come inside, and what it will do, S will be equal to 0 and L will be equal to 10. Done. When in the next case it will come 10 is not greater than 10, so it won't go inside, so it will come to else part. Here also it should not be equal to L is written. So this, because this is not equal to 10, should be there, and here we are having the AND operation, so it won't go inside here as well. So every time it will go back over here, then it won't come inside, it will go back, so there won't be any change in the value of S. So what we are doing, if you are taking it as 0, then I will have to write here 0. If you are taking it as int min, then I have to write here as int min. If it is equal to 0 or int min, then we can say that there is no second element. All the values are, or you can declare here, all values are same. You can declare this thing. Okay. This is how we talk about how to find out the second largest element. We can also talk about a number of operations on the matrices as well. Here in this case, if you are having this array, you are having this array, then what you can do, you can find out the individual addition of the array elements as it is shown over here. C0, which is a new element, is equal to A0 plus B0. Yes, it can be done. C1 is equal to A1 plus B1. So simply in this case, what you will have to write, you will have to write a for loop where I will be 0, I should be less than 4, I plus plus. And within this loop, you can simply write Ci is equal to AI plus Bi. Okay. And this is closed. So using this single statement, you will be able to calculate this thing, and you can directly print the value of C array where it is having the addition of the two arrays. The same can be done in the case of three-dimensional array as well. Sorry, two-dimensional array as well. Simply what you can do, you can take the individual values here. J I is equal to 0 to 3, and j is also from 0 to 3. And what you're doing, you are having a third array, and you are finding out the addition of the two array, individual values of the two array, right? This is addition of individual values of the two array, and we are trying to store it in the third array, right? So it can be done using this for loop. So this is adding all the values of an array, simply using a sum step. If you remember anything, if you want to find out the sum, then initialize that with value to 0, and you write this statement, sum is equal to sum plus that value. So here it will go on changing the individual values of the matrix, and you will be able to find out the summation of the whole matrix, right? So this way it can be done. There are various other things as well which can be done here. If you see this one, they are trying to find out the addition of the rows, columns, or the diagonals. If you want to find out the addition of the row, if I want to find out the addition of the row, for example, if I am having this matrix, I will repeat that thing here. I am having this matrix which is having 2, 4, and 1, 3, 5, and 2, and 4, 6, and 1. What is the column wise addition? So this is 7 here, this is 10 here, and this is 11 here. Similarly, if we want to add it row wise, then it is 7 and 2, 9, 15, and 4. So this is manually how you have done. If you want to add these three values, you have to understand the concept that what are the values of the rows and the columns. So if this is I, so I is equal to 0, 1, and 2, and this is column that is 0, 1, and 2. So basically what you are doing, you are keeping the value of j as 0, and you are varying the value of I as 0, 1, 2. So what you do, you keep the value of j constant, and then within that you have to write the columns. If I try to write this thing to you, simply what will be required? J will be required outside. Within this for loop, what you have to write, you want to store it in some array. Say there is this array C which is having three values. Okay, so the first value will be 7, second value will be 10, and third value will be 11. This is what I want, right? So what I will have to write, I will change according to the value of J, correct? So Cj is equal to, what you are trying to do here, you are trying to add all the values of uh, the column. So what value will be changing if the name of this array is say A, then Cj, if you initialize the values of all three to 0, then Cj will be equal to Cj plus Aij. Is it correct or not? Try it. If I am taking the value as 0 for I, so 0 comma 0 will be the first value. Then if I changes to 1, then it will be 1 comma 0, and then it will be changed to 1 comma 1. Okay, so Cj means C0 will have the value of 7. Then if when J changes to 1, then it will be again 0 plus A 1 0. So it will be your first value of the second column, then 1 1 and 1 2. So you will have all the three values which will be stored in Cj. So is this concept, is there any doubt in this concept? So what you will get is the summation of the columns. Similarly, you can write logic for the summation of the row values, or the diagonal values, or the upper triangle of the matrix, or the lower triangle of the matrix. So all these things you have to try on your own. If you have any doubts, then we will discuss in the next class. Next concept is the linear search. Basically, what are search algorithm? First thing is, what are search algorithm? You have one array. Say I am having a number of elements here, 5, 7, 9, 3, 2. I am having these elements. Now I want to check whether 9 is there or not in this array. I don't know the array, but I want to find whether 9 is present or not. For example, I have taken the attendance of the class directly from the WebEx. Okay, and I have stored it somewhere. Now I want to check whether today roll number 9 was present or not. So basically, what I have to do, I have to search that 9 in that particular array. Okay, so I will have to search this 9 in this particular array. So there are two methods of two commonly known methods. There are multiple methods. So two commonly, or base methods rather, we can say, of doing it. First method is the linear search. Linear search is nothing, just you go to everybody and ask whether you are 9. No. So I will go to 5 and ask whether you are 9. No. Then I will go to 7 whether you are 9. No. I will go to 9 whether you are 9. 9 will say yes. So as soon as it says yes, I will say yes, 9 is present. 9 was present today in the class, right? Say if some element is not present here, say if I am searching for 6, so what I will do, I will go to 5. Whether you are 6, no. 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 So if till end I couldn't find an answer whether you are 6 or no, then in that case I will declare that this element is not present in the array. So roll number 6 was not present in the class, for example. Okay, so this is the base method, or the most common method, rather we can say raw method, we can say, of doing it, which is known as linear search, or it is also known as sequential search. It is also known as sequential search. Now, what happens in this case? In this case, the array is unsorted. There are two types of arrays. One is sorted, another one is unsorted. Sorted means we have arranged them in increasing order. Then this is known as a sorted array, but this one is unsorted array. So linear search can work on both. Okay, it can work on unsorted as well as sorted array, no problem with it. But when we will come to the next one, that is the binary search, it only works on the sorted array, not on the unsorted array. So here in this case, it is explaining how we are doing it. This is an array which is having 5 elements: 27, 32, 56, 79, and 21, and we are trying to search 79. In the case of search, we call that value as the key. The value which is to be searched is known as the key. So what we will do, we will keep this value as key. Key is equal to 79. Now what we will do, if key is equal to first value, so this is a, first value is 0. No, it is not equal. Then what we have to do? Go to the next value. So if key is equal to A1, then next if key is equal to A2, no, and so on. Right? So this way we go on comparing the values, and finally when we get here A3 as 79, we declare yes, we are successful. But if you see, if for example I am having an array which is having a length n as 1000, n as 1000 means length as 1000, so there are 1000 elements. So there are 1000 elements in that array. And if your element key, for example, key is 79 only, and it is at the last location, it is at the thousandth location, then what will happen? How many times you will have to compare? You will have to compare compare 1000 times. So that's why in the worst case, that will be the worst case, no? That whatever you were searching for is sitting in the last. You, for example, in a class, you are searching for a student. You are going to each and every student. Uh, Shreyansh, you asked about the last slide. I hope we can use a loop here. In this case or in the last slide you are asking? I couldn't see your question. Sorry for that. If you're asking about this one, in this case, yes, loop will be used. Definitely, loop will be used. So in the worst case, you are searching for a student in a class, and for example, 200 students are giving the examination. You are going to each and every student, and you are checking the identity card. Yeah, instead of so many, if we will use loop only. This thing I have written just to explain the concept. So we are not going to use this many ifs. No, we are not going to use so many ifs. रख जाइए अभी क्लास चल रहा है ना ओके So the worst case is that a student is sitting in the last corner. So you started from the first student, and you will have to check the identity card of all the 200 students. Then only you could identify the student who is having that name or roll number. Okay, so that is the worst case. So in worst case, what will be, how many times you have to compare? It is n times you have to compare. That's why we call it as order of n comparisons will be required. And in average cases, best case will be when you want to search a student and student is sitting at the first position, so order of 1 will be there. Student is sitting as the first position only, and in average case it will be the middle value, not the highest value, not the least value, it will be middle value. Okay, so we can say like this, right? So this is simply how we are going to compare the values. Right now, as Shreyans also said, that why we are writing so many ifs. Instead of writing so many if, can't we use a for loop for that? Yes, we will use a for loop for that. This is the algorithm for this thing, where what we are doing, we are taking three variables. I is equal to 0. I is for taking the loops. Position, POS is used for finding out the position where you found that number. For example, you found that number. If I go to this one, for example, I found 79 at third index. So I want to store this third index as well. I have some mathematical manipulations to be done on that. So I want to store this as 3 as well. So I will store this in POS, that is position. Then we are having one flag variable, which will simply tell us whether you could find out a element or not. And here what you're doing, you are repeating the statement. It means you will require a for loop over here. These two will be in for loop. Simply what you will be doing, you will compare the value with the key. If it is true, then you will store the position in POS, and you will set the flag to 1, stating that yes, I have found, and break it. And once you have done this thing, if flag is set, it means that you have found the element. And if flag is 0, then we can say that no element could not be found. So if I try to write a program for this thing, wait. So this is simply linear search. This is using the concept of array. Sorry, this is using the concept of function. This is without function. First of all, we will see without function. We cannot use break in if loop. Yeah, I will come to that. Wait. I got your question. That's correct. Here, what we are doing, we are taking number of elements. We are trying to read the elements from the user. Wait a moment. Varun, right now class is going on. I said that call after class. Yeah. So in this case, basically, we are trying to read the elements from the user, and we are trying to read the element to be searched from the user as well. After that, we used a for loop, and in this case, we have used a break statement for loop, not for if statement, right? Here, this is if statement uh, thing is missing here. Here, what we have to do is we have to set the flag. We have to declare POS is equal to I here, and we have to declare POS here. And then POS is done, then there is a break, and then it should be a curly bracket here as well. And then we will close the for loop here. Yeah, this should be like this. I hope this answers your question, Dinesh. right? So this way we can, and here what we will be printing is POS. Okay, sorry. This way we are doing it. One thing that I missed in one program, wait, this will be required everywhere. I missed this to explain. Here what we have done, here you can see that we are defining one array. There is one function. If you see, this is one function input. This, till this point, this is one function input where we are reading the array. If you see, array is passed as argument here. Okay, how to pass array as argument, and how to pass the array as argument, it is shown here. Here if you see, this is array A, and what we are doing, we are sending this array as argument. Simply write the name of the array. If you simply write the name of the array, basically what you're sending here is, I will use, say address is 1000. So what I am sending is address 1000. Okay. What will happen here when you are taking it as argument, formal argument, actual argument was there, then what you have done here, you have declared one array B. So when you have declared this array, basically you are not creating a new array. It is the same array, but you are assigning a new name. It is something like that you are having a different name at your home, and in your institute you are having a different name. It is something like that. It is basically the same array, just the name will remain different. And what you will be doing is you will be using this name throughout this function for the same array. How this can be proved that this is the same array? Whatever changes you do here will be automatically reflected in your main program. Okay, so if in this case, simply what we have done in the main program, simply we have created one array A and we have not assigned any value, and we have sent that array as input. So here what you are sending, what is this thing? This is basically 1000. What was 1000? 1000 was the address. So what you have sent here is that address, and we have created a new name for that address, that is B, right? So now whatever changes you are doing will be reflected in the same array. So if you're having if you're writing here printf enter 10 values, and you're using a for loop, and you're reading the values from the user, and you're not returning anything, then also when you print the result in the main program, then your actual values which you have read in the function will be reflected. So I will try to compile and run this one and show it to you. So enter 10 values. So if I'm writing 1 2 3 4 3 2 4 2 5 6 7, then 4 3, you can see the same values are reflected from the main program. So what does it mean? We are not creating a different array. It is the same array. When you are sending the array from the main function to the function input, then what you are sending the base address, and now everything will be done on the base address only, right? So this is how array can be passed. The same thing I have used in this one. If you see, this is a function which is known as a sequential search. Here we have sent the array L. This is the total number of elements in the array, and this is the key to be searched, right? And we have used this function for finding out the search and the index to print the index. And in the main program, we have just invoked this function, or just call this function. What we are sending is simply the name of the array. If you see, this is the total number of elements in the array, and this is the key to be searched. So if I try to compile and run this one, then you can see index is 6 of 6 is 4, means key was 6 and the index at which 6 is stored is 4. Okay, so I hope this answers the question as well as clear all the doubts. So if you have further any queries, you can ask, else we will close the meeting.
Ma'am, have you checked our papers?
Voice is not audible, Shreya.
Ma'am, have you checked our papers?
Yeah, tomorrow I will give you the marks, I said.
Oh, okay. Ma'am, your laptop is, I think, fully charged. You can remove the charge.
It is showing that thing,
Yes,
but it is
ma'am,
not
it's
showing
showing
that.
fully charged.
Okay, 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 fine. Thank you. Okay, any other question? Batch wise quiz marks will be displayed in this week only, right? Okay, so we will close the meet for today.